Okay, so far we talked about completing the square and we talked about how to solve things when it's in the form of some variable plus or minus something squared equals a number. So now we're going to try to fit all quadratic equations. So let me write the generic quadratic equation. So ax squared plus bx plus c equal to 0. So here is a quadratic equation. And we've done things like x minus 4 squared equals 5, right? And we talked about completing the square. So what we're going to do is follow that procedure. So let's go step by step. And then if you have any questions, please feel free to email me. Okay, so the first step of completing the square was to divide through by a so that we could have the leading coefficient be 1. So divide through by a. Divide by a. So we get x squared plus b over a x plus c over a equals 0 because 0 divided by anything will be 0. So now we have it in the form where the leading coefficient is 1. And to complete the square, we look at this term, right, the coefficient of x. We half it, and then we square it. Right, so that's the same procedure from the completing the squares portion. So we have x squared plus b over a x. And before we do that, we could take the c over a to the other side by subtracting it. So subtract c over a over. And so let me talk on the side. So b over a, halving it is the same thing as multiplying by 1/2. And then we square it. So we get b squared up top, and then 2 squared is 4, and then we have a squared. Okay, and whatever I do to one side, I have to do to the other, so I'm going to do plus b squared over 4a squared, and then plus, sorry about the other part, b squared over 4a squared. So now I have this, right? It's a perfect square, so I can factor. So I have x plus b over 2a squared. And you can check that by foiling or multiplying it out vertically, or you can use the box method or whatnot. And then on the other side, I need to get a common denominator because I'm adding, right? So to c over a, I'm going to multiply each part by 4a. So I get negative 4ac. I get 4a squared plus b squared over 4a squared. I can combine these, right? Because now I have a common denominator. So I get x plus b over 2a squared is equal to negative 4ac plus b squared all over 4a squared. So now we have it in the form something squared equals some other expression. So at this point, we can take the square root, but note that when we take the root of things, and it's an even power, if it does exist, we have two separate ones. So we're going to say x plus b over 2a is equal to plus or minus square root of this entire thing. So negative 4ac plus b squared all over 4a squared. So the top part, there's not much we can do, but for the bottom part, 4 is a perfect square, and if we have 8 squared, we can take the square root of that. So this part becomes x plus b over 2a, so I'm going to leave that part alone, is equal to plus or minus square root, right? Because the square root, I can have the numerator and the denominator separated. So negative 4ac plus b squared. And the denominator, square root of 4 is 2, square root of a squared is a. And finally, if I want to solve for x, I subtract b over 2a. So I get x equals, I subtract it over, so negative b over 2a plus or minus square root of negative 4ac plus b squared all over 2a. And since the denominator is the same, I can just write it as one fraction. So I could write negative b plus or minus square root of negative 4ac plus b squared all over 2a. And this is where the quadratic equation comes from. So we know how to complete the square, and then once we do that, we can factor it because it's a perfect square. And once we factor it, we can take the square root, keeping in mind that it's going to be plus or minus, and then we solve for x. So none of these steps are things that we haven't seen before. It just might be really overwhelming because we're not dealing with numbers and I have variables in place because we're trying to solve it very generically. But now we have this useful tool that we can use to solve all the quadratic equations. So that's what the next video is going to be about.